Good day, everyone. So today we'll be talking about Introduction to Trigonometry. Let us first define trigonometry. Trigonometry came from three Greek words: tri, which means three; gono, which means side; and metron, which means measure. Okay? So trigonometry came from three Greek words: tri, which means three; okay? So gono, which means side; and metron, which means measure. So in other words, what is trigonometry? Trigonometry is basically the mathematics of triangle measurement. Okay? What is trigonometry? It is the science of triangle measurement. Right? So trigonometry deals with the measurement of triangles and the interrelationship of the sides and angles of the triangle. Okay? Now, let us proceed to angle. What is an angle? An angle is a geometric figure formed by two rays having a common endpoint. Do you know what a ray is? Okay, so a ray is looks like this. Suppose you have like this figure. Okay, this is ray AB. Okay, now the vertex of an angle is the common endpoint, and its sides are the rays forming the angle. Okay, so for example, we have figure on the left, ABC. We have ray BA and then ray BC. And then they meet at a common endpoint B, and then the opening is called the angle. Okay? So it is considered as the figure formed when two lines meet, okay? Or the two rays meet. Similarly, it is the figure formed by rotation of a ray about its vertex. Okay? So, for example, in this figure, we have two rays, BA and BC. The opening is what? An angle. So now, B is called the vertex. B is called the vertex. That is the common endpoint between the two rays. And what is the opening? The opening is the angle. So here, on the left, we have a rotation which is a counterclockwise. Alright? So that is the sense of an angle. So it is considered positive if the rotation is counterclockwise. Okay, this is in counterclockwise rotation. How about on the left figure? We have a clockwise rotation. So if the rotation is clockwise, the positive is a negative angle. Okay? Now, how about in naming an angle? So we can name this angle as angle ABC or angle CBA. Notice that the vertex is located at the middle of the name of the angle, right? So angle ABC or angle CBA. You cannot name this angle as angle ACB. No, because the vertex must be in the middle of the name of the angle. Okay? Okay, let us name the second angle. So we can name the second angle as angle FED, right? Or angle DEF because the vertex is E, right? Or sometimes the angle can be named as or using number. For example, this one, angle 1 or angle 2. So here, we can name this angle as angle 1. And on the right, we have angle 2. Okay? So, ray BC is called what? The initial side, right? So, BC here, BC, ray BC, okay, this is ray BC is called the initial side. Okay, I am talking about the left side, the left angle. Okay, and ray BA is the terminal side. Okay, or simply BA or BC. BC is the initial side, BA is the terminal side. How about on the second angle? So EF is an initial side and ED is the terminal side. Okay? Let us proceed to the size of an angle. So the size of an angle is given by the amount of rotation of the ray. So it may be expressed either in degree measure or in radian measure. So before going into the degree measure and the radian measure, let us categorize the different types of angles according to its size. Okay? Number one, we have acute angle, right? Acute angle. So what is an acute angle? So this angle is angle between between what? 0 degrees and 90 degrees. Okay? So in interval, we have 0 degrees, 90 degrees. So 0 degrees is not included and 90 degrees is also not included. Now, next angle is called the right angle. So this is simply the angle measuring 90 degrees. Okay? So we are familiar with that. If you have like this angle is the 90-degree angle. Okay? The next type of an angle is called obtuse angle, right? Obtuse angle. So obtuse angle naman is what? An angle measuring what? Angle measuring between 90 degrees and 180 degrees. Okay? So in interval, we have 90, 180. Okay? Greater than 90, but less than 180. So that is obtuse angle. Next is called straight angle. So a straight angle measures 180 degrees. Okay? So something like this, right? Straight line. Straight horizontal line. Okay? Now, the next one is called the reflex angle. So reflex angle measuring between 180 degrees and 360 degrees. Okay, so in interval we have 180 degrees, 360 degrees. So open interval. Okay, so reflex angles are angles between or more than 180 degrees but less than 360 degrees. Okay, now let us proceed to the degree measure. So the degree measure, this is indicated by a tiny circle placed in the upper right corner of the number representing measure of the angle. So the size of the angle produced by one complete rotation is equal to 360 degrees. Thus, 1 degree is equal to 1 over 360 degrees because one revolution is 360 degrees, right? So a complete revolution is 360 degrees. So 1 degree measure is 1 over 360 degrees. So the size of an angle is given by the amount of rotation of the ray. Okay, let's proceed. So let us proceed with the conversion. 360 degrees is equal to what? 1 revolution. And 1 degree is equal to 60 minutes, right? So 60 minutes can be written as 60 apostrophe, 1 apostrophe. And 1 minute is equal to 60 seconds. So 60 seconds, 60 double apostrophe. So seconds, double apostrophe, minutes, 1 apostrophe. So therefore, 1 degree is equivalent to how many seconds? That is 3,600 seconds. Okay? Now, let us proceed to the radian measure. 1 radian is an angle, okay, which if placed with its vertex at the center of the circle subtends an arc equal to the radius of the circle. Thus, the radian measure of a central angle of a circle, so theta, Theta, an angle formed by two radii. So its vertex is the center of the circle, and the radii are its sides. So it is the ratio of the intercepted arc S to the radius R as noted in figure 1.2. Okay? So in this figure 1.2, we have a center point, this is the center point, and then connected to the other point on the circle, so that is ray. So that is a radius, right? If the center is connected to the point on the circle, that is the radius. So another radius, and then so they meet at the center of the circle. So this is the vertex, and we have radius, radius. The two rays representing the radius. Okay. So this opening is theta. Okay, and we have intercepted arc S. So now, especially in geometry, we know that the intercepted arc equals the radius times the angle. So we are talking about the central angle here, right? Now, we have a memory aid for the formula because S is the intercepted arc is equal to the product of the radius and the angle theta. Okay? So if you are looking for the radius, radius is equal to S over theta. If you are looking for theta, what is the formula? S over the radius. Okay? Now, on the ratio S over R, that is theta, right? Theta is equivalent to the intercepted arc S over the radius R. Okay? On the ratio S over R, units cancel out, leaving only a number for the measure of the central angle, right? So what is the central angle? Intercepted arc S over the radius R. So there is no unit associated with radian measure. When no unit is specified, it is assumed that the angle measures is in radian. Okay? If no unit, automatically it is assumed that it is in terms of radian. So thus, angle pi over 4 means an angle which is pi over 4 radian. Okay? Now, let's proceed to the relationship between degree and radian measure. So 360 degrees is equal to 2 pi radian, right? Because, okay, we have this illustration. So this is 0 degrees, or 0 degree. This is 180 degrees, right? Because a straight line, type of an angle, di ba? So we have a straight line measuring 180 degrees. So if this is 180 degrees, from this initial side to this side, that is measuring 180 degrees. Okay? 180 degrees, and then you proceed with this one. So 180 plus 180, 360 degrees. Actually, that is one revolution. Okay? So one revolution. So 360 degrees, which is one revolution, equals 2 pi radian. Okay? Now, if 360 degrees equals 2 pi radian, okay, so what is 1 radian? So let us divide both sides by 2. So that is 180 degrees equals 1 pi radian. So that is pi radian. So therefore, we can also say that 1 radian, okay, divide both sides by pi. So 1 radian is equal to 180 over pi. Okay, actually this one. Okay, so the box relations will be used to convert degree measure to radian measure and vice versa. It must be understood, however, that when no other unit of measure is indicated, the angle is expressed in terms of radian measure. Okay? Now, let us proceed to some examples. Let us convert an angle in degree measure to radian measure and vice versa. Okay? So suppose you have 60 degrees. What is 60 degrees in radian measure? Okay? So 60 degrees equals 60 degrees times what? So the conversion factor that we are going to use is pi over 180 degrees, right? Radian. Now, because degree here, so degree here, we can cancel the degree measure. And the remaining unit of measure is radian. So now, actually, we can cancel out 0 here. 6 over 18 is what? They are both divisible by 6, so this is 1, and this is 3. So the answer is pi over 3 radian, or simply pi over 3. Okay? Now, another one, 150 degrees. 150 degrees is equivalent to how many radians? So let us multiply again by pi over 180 degrees. So cancel, 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 cancel. So they are both divisible by 3. So this is 5, right? And this is 6. So the answer would be 5 pi over 6 radian, or simply 5 pi over 6. Now, let us convert radian to degree measure. Example, what is pi over 2 radian in degree measure? Okay, this is pi over 2 times 180 degrees over pi. Okay? So cancel, cancel. What is 180 over 2? That is 90 degrees. Okay? Now, another example. 10 pi over 3. What is 10 pi over 3 in degree measure? Okay? 10 pi over 3 radian multiplied by 180 degrees over pi. Now, they are both divisible by 3, right? So we can cancel out. This is 1, this is 60, right? So the answer would be 600 degrees. Okay?